Today we'll talk about the fundamental counting method. We need to start with a few definitions. So the first definition we need to discuss is an experiment. And I think an experiment is something we're all familiar with, but then we got to throw a definition around it. So let's say an experiment is an observation of a random phenomenon. So it's just something that we do and then we wait and see what happens. The thing that happens we call an outcome. So an outcome is just any result of an experiment. An event would be a set of outcomes of an experiment. And we'll talk about later some examples of what that would look like. And then a sample space is going to be the set of all the outcomes of an experiment. So an experiment can have a lot of different things that can happen, but when we say here are all the possibilities, we'll call that the sample space. We're going to use the sample space a lot as we talk about probability and counting methods. So sometimes you will see that I will use an S just to represent sample space so that I don't have to write sample space every time. So let's take an example of what an experiment could be, and let's keep it easy and just say like we flip a coin. Then the sample space just has two elements, heads or tails. Those are the only things that can happen. Another experiment we could discuss would be rolling a six-sided die. The sample space then would be, what are the things that can happen? Well, I could get a 1, a 2, a 3, a 4, a 5, or a 6. So I have 6 elements this time of my sample space. If I wanted to talk about an event, which would just be a subset of the sample space, let me give you a couple examples. Like A, I could have the result is even. So then that event would just have 2, 4, and 6. Or if I want to talk about the result is greater than 4, then that would just be 5 or 6. All the time as we're talking about different sample spaces and events, we want to make sure we pay attention to the words and that we're really picky. So greater than 4 does not mean greater than or equal to 4. You have to really watch for greater than, less than, not. Just pay attention to the wording so you don't get messed up with it. So the counting principle. Sometimes we want to know the number of ways we can do an experiment, but don't need a list of all the different sample points. So for our examples, we will call the part of the experiment task. If an experiment has n different tasks, x1, x2, x3, all the way up to xn, then the number of points in the sample space is x1 times x2 times x3 times up to xn. It just means that we multiply all the ways to do each task together to find the number of ways to do the experiment. Let's make that easier. Let's take an example. We're planning a catered lunch. A company is having lunch catered for an upcoming conference. Each person is told to select one item from each category of the following menu. So for sandwiches, they can get tuna, vegetarian, or ham and Swiss. For a side, they can have potato chips or a pasta salad. And for dessert, they could have a cookie or a fruit salad. So what we want to decide is how many ways could the lunch be ordered? To answer it, we need to look at there are 3 ways to select a sandwich. There are 2 ways to pick a side and 2 ways to pick a dessert. The number of ways the lunch can be ordered would be 3 times 2 times 2. So we look at how many ways we can do each part. We are multiplying those together, and that gives us 12 ways that the lunch could be catered. Let's do the same thing and switch to jackets. So how many ways could you order a jacket if it's available in 4 sizes, so small, medium, large, and extra large, 4 colors, blue, red, orange, or green, and then could be ordered as either a man's, a woman's, or a child's size? So again, we have to look at what are our things that we're putting together. So first we have to pick a size. We have 4 choices. Then we pick a color. We have 4 choices. And then we have to pick if we're ordering a man's, a woman's, or a child's. That's 3. So here I multiply 4 times 4 times 3, and it says there are 48 different ways to order the jacket. Making a password. Let's look at how many 4-digit passwords can be made using the numbers 1, 2, 3, 4, 5. But let me give you some conditions. The first condition is what if repetition is allowed? So I have 4 things I need to do. I need to pick a first number, a second number, a third number, and a fourth number. I had 5 choices for my first number, but because it says repetition is allowed, I also have 5 choices for my second, my third, and my fourth number. When I multiply that together, which is the same thing as 5 to the 4th, I get 625 different passwords. Let's look at what if we weren't allowed to repeat. So I would still have 4 blanks, but this time I have 5 choices for the first number and only 4 choices for the second. So what's happening here, when repetition is not allowed, I'm subtracting 1 every time I select something. So from 4, I drop to 3 and then to 2. So now 5 times 4 times 3 times 2 says I have 120 passwords if I'm not allowed to repeat. Let's do the same thing, but let's add to it. Let's say how many passwords can be made using 2 letters followed by 4 numbers. In this case, we're going to say capitalization doesn't matter. So when I'm picking a letter, it doesn't matter if I pick uppercase or lowercase, it's the same. And again, I broke it into part A and part B, which is repetition and no repetition. So in part A, I have 2 letters and then 4 numbers. Repetition is allowed, so I say there's 26 letters in the alphabet, and because I can repeat, I have 26 choices for each of my first and second choice. So there's my letters. Then I go to numbers. It's really important when you think about numbers that you realize you have 10 choices. You have the numbers 1 through 9, but you also have this choice of 0. So anytime you're asked to pick a number, unless specified otherwise, you have 10 choices. Again, I have repetition allowed, so it means I have 10 in those 4 spaces. So what I'm going to put in my calculator is 26 squared times 10 to the 4th. I think that's easier to do it that way. I don't have as many numbers to enter, and the less numbers I have to enter, I'm more likely to get it right. Right, so this gives me 6760000. So let's put some commas in there so we can see this is 6,760,000 ways. It's going to change when I take repetition away. So I'm still going to have 2 letters and then 1, 2, 3, 4 numbers, but now every time I pick something, I reduce my choices by 1. So I started with 26 choices, which quickly drops to 25. Those are my letters. For the numbers, I start with 10, drop 1, it's 9, drop 1, it's 8, and drop 1, it's 7. So this time I have 26 times 25 times 10 times 9 times 8 times 7, which now is 3,276,000. So you can see I have a lot more passwords if I allow repetition than I do if I don't allow repetition. So I'm going to try that again. I'm going to make it a little harder and say capitalization does matter. So there's a difference between a lowercase and an uppercase letter. So what this immediately does is increases the number of choices I have. So when I pick my 2 letters, I no longer have 26 choices, I have 52. So that's 26 plus 26. 26 lowercase, 26 uppercase, which is 52 altogether. Part A again says you're allowed to repeat. So I have 52 twice. And then those 4 numbers again are still all 10s. Okay. Because I can, I'm going to put that in as 52 squared times 10 to the 4th. So here's what I have, 27040000, and let's count 1, 2, 3, 1, 2, 3. So there's 27,040,000 choices if I change to upper and lowercase. Again, we know what happens when we take away the repetition. Now I have 52 choices, followed by 51, and then 10, 9, 8, 7. So 52, 51, 10, 9, 8, 7. And again, I like to put in my parentheses. So now I have 13,366,080 different ways to pick a password where I do care about capitalization if I'm not allowed to repeat. All right. Big picture, you're supposed to be getting that this is multiplication, and really you're always asking yourself the question as, does order matter? Is repetition important? So I'm telling you in these if repetition matters or not. All right. So how about I give you a try? How many ways can a couch be ordered if it comes in 3 materials, leather, sweater, cotton, and if each material is available in 15 colors? So give yourself a second, pause me if you need to, then come back and check out how you did. All right, so answer. Remember, we had to start with, there were 3 materials, so you have to pick one. You pick a material. Each of the material comes in 15 colors, so I have to pick one. So 3 times 15 says there's 45 ways to order this couch. Let's look at this, finding the missing information on a license plate. Look at the picture on the right. If we look at the plate and know that it has 3 digits followed by 3 letters, how many plates could be made that start with 8 and end in S? So I have this plate, and I know the first one is an 8, so I don't have to guess what it is. I know the last one's an S, so I don't have to guess what it is. But I told you that it's made with 3 digits, so I need 2 more digits, and then I need 2 more letters. So nothing says that I'm not allowed to repeat, so I'm going to say I can. So it says there are 10 choices for the second letter, 10 choices for the third letter, and then 26 choices for each of the missing letters. So I have 10 times 10 times 26 times 26, which says 67,600. My idea for this is, think about how many times you hear about there was an accident or something, people saw part of the license plate, and you think, well, how much does that help me? It helps me, one, if I know the strategy behind how license plates work, which aren't necessarily what's going on here. It's not necessarily going to be 3 numbers followed by 3 digits, but if it was, it would give us something to go on. It would tell me how many things would I have to look at, and you could see how much detective work would be behind trying to track down license plates. All right, so let's continue our discussion and say, be careful with the word numbers. And let's say, how many 3-digit numbers can be formed from the set 0, 1, 2, 3, 4? All right, so you start thinking 3 numbers, and from the set 0, 1, 2, 3, 4, and I think, well, how many choices do I have for a first number? And the answer is 4. Now you can see clearly there are 5 digits here, but I said there's only 4 choices. And the reason is, when I talk about a number can't start with 0, right? If we did, like say somebody was 24, if I put a 0 in front of it, they're still 24. They haven't become any older just because I put a 0 in front. So we want to say, with numbers don't start with 0. Now that I've picked the first number, then the second and the third number have 5 choices. Numbers are allowed to repeat. I'm sure all of us have been 11. Some of you have been 22. I've already been 33, right? So we can say that definitely we're allowed to repeat when we look at numbers, but we just know we don't start with 0. When I put this together, 4 times 5 times 5, I get 100. So let's do it again, and I just made the set a little bit bigger, and this time I'll give you a minute to try. How many 4-digit numbers could be formed from the set 0, 1, 2, 3, 4, 5, 6? So pause me, answer it, then unpause me, and see what you got. All right, so I started by drawing 4 slots, right, because I have to pick 4 digits. In the first one, I say I have 6 choices. There's 7 numbers, but I can't use 0. The other blanks, I'm putting in 7. So I have 6 times 7 times 7 times 7, or 6 times 7 cubed, which says 2,058. Now let me change it just slightly and say how many 4-digit numbers can be formed from the set 0, 1, 2, 3, 4, 5, 6. But I'm telling you the first one's going to be a 2 or a 6. And then the last one is a 2 or a 6. Okay. And the reason, who knows? I just pick, like, let's do something different. So we're going to say how many of our numbers start with 2 or 6. Well, that means there's 2 choices for the first one. There's 2 choices for the last one. In the middle, I have 7 choices for each number. So here I have 2 squared times 7 squared. So 2 squared times 7 squared is 196. Let's lastly look at how many ways could you take a multiple choice test. So let's start small. Say I have an 8-question true or false test. I want to know how many ways could it be answered. So here I have 1, 2, 3, 4, 5, 6, 7, 8 blanks. True or false means there's 2 choices for each of the questions. I'm multiplying all of these together. So let's just put in 2 to the 8th into our number of ways to do it so I don't have to hit 2 times 2 times 2 so many times. So it says there's 256 different ways to answer a true or false test if there are 8 questions. So let's change it. What if I make it, how many ways can a 10-question multiple choice be answered if there are 4 choices for each question? And now let's try to simplify this a little too. So I know I have 10 questions, but 4 choices. So I have 4 choices for the first one, 4 choices for the second, 4 choices for each one. So instead of writing out 10 blanks, I'm just going to write, I have 4 choices 10 times. So there's 4 to the 10th. Putting that in my calculator, here's what I get. And again, remember, I like to put in my commas. So this is 1,048,576 different ways to answer this test. All right. How about this? What if I had 12 questions and there were 5 different choices for each question? Try it for a minute. Pause me. See if you can answer it. All right. So here's what we're thinking. I have 5 different choices, 12 times. So I have 5 to the 12th. So here's my number, 244,140,625, and the commas, so I can read it well. 244,140,625 different ways to answer that test.